Hello everyone, it's been a while since the last episode of the TinyM, but today, well in this video anyway, we will be continuing to build. But since it's been a while, I thought I should just do a recap of what we did and what the project is. So here it is, the entire aluminum frame here. And yeah, as I said, as the name suggests, this is a TinyM Doom. So if you look inside, you can see the tiny M-ness of it, and if you don't know what a tiny M is, it's basically a large Voron Zero with 2020 extrusions. But this is a heavily modified design. There are a lot of changes from the stock tiny M, and the biggest change obviously is the fact that this is also a insulated printer, so that's where the name Doom comes from, even though I never asked if I can use that name. Anyway, yeah, that's where the name comes from, so this will be insulated. It will have double wall insulation, aluminum panels in the center, and then insulation, and then outer steel panels. That's the idea. This also has a filament drawer here that I think it was in the last episode. I only did this because I think it looks cool, not because it's really necessary, but yeah, it's nice and it works really well. This is an entire piece printed in ABS, and I'll put up a clip of this if I can dig it up from the last episode of this theoretically working. But yeah, that's the printer. And yeah, the heat bed is the standard 150 by 150 bed here. Yeah, it's a 150 by 150 bed, has a 120 by 120 heater from Keenovo. It's a 24 volt DC for my setup, 120 watts. This wasn't available from Keenovo store at the time, so I talked to them and they decided to list it. So if you are building a TinyM for any reason, not just this specific TinyM, but any TinyM, I think this is a better heater now that it's available, because otherwise the 100 by 100 feels kind of small to me. And here we have all the rest of the panels, the steel panels and the aluminum panels. So as I said, aluminum in the inside, steel on the outside, and the steel panels are covered with a matte black vinyl wrap. And yeah, I think it will look pretty nice. Now there are a few changes from the initial plan. I was hoping to print this whole thing in cf-nylon, high temperature cf-nylon, so cf-ppa from 3D Tech, and that is still the plan, but I'm recording this mid-October and I plan to move in at the latest early December, so yeah, I don't have much time, and the problem is my Voron 2. It's not in working condition at the moment, and I don't feel like I have enough time to fix that, then print that, the parts, and then finish the TinyM. So for now I'll be printing all the parts in ABS on my Voron Zero. After the move, if I can bring these printers with me, which is what I hope to do, but it's a bit complicated. I think I haven't recorded it yet, but I plan on making a channel update on that, and it's probably live by now. But yeah, anyway, the plan is to reprint this whole thing after the move in that cf-nylon material. There are also a few changes from the last episode. Yeah, first of all, I didn't know what extruder I wanted to use at the time. Now I know. It's this triangle lap orbiter extruder I got, and yeah, it's just an orbiter. It's a lightweight extruder and it should work in high temp environments. And part of the reason why I chose this is because it's printed in high temp resistant materials, so yeah, it should work well in there compared to a 3D printed one, which getting the tolerances right on a 3D printed extruder is more difficult than the rest of the printed parts for a 3D printer, and as I said, I want to use cf-nylon, so I thought this would be the safe direction for that. I'm still using the Dragon hot end as I planned, so this is the high flow V2 Dragon I bought for this project. I also use a V1 on my Voron 2, but yeah, this is what I want to use here. And the reason I'm not going with a Revo or anything like that, because A, they don't have a high flow variant, and B, they don't have a high temperature variant with a higher temperature sensor and stuff like that. So without both of those, yeah, I'm sticking with the Dragon. But once they actually release a high temperature and high flow variant, if I'm building a new printer after that, I'll definitely consider it, because I do like the Revo. But for now, let's get to printing these, and well, I've already done that, recording this in the future. I do like looking at time lapses, so I will include a whole bunch of them right now, but if you want to skip them, there are timestamps in the description below and probably on the timeline as well, but otherwise I'll be back with some progress on the printer. I printed all the parts for the Tiny M except the ones that I'm replacing with newer designs, and also did some part of the assembly. So here you can see the bed assembly. As I said, this is basically a Boron Zero. The gantry, it's a little different. Obviously it's still based on the Boron Zero, but it's a little different, especially on mine. Since I'm not using the top extrusion here for spacing, etc., I have an M3 screw here that's keeping this in place, and these they're basically the same, but overall I also made these taller. I don't really remember the reason why I did that, but there must have been something. Did this design a while ago. You can tell by the fact that the last episode was a while ago. But yeah, you can see that I mounted some of the electronics, and this is how the installation is going to work. So here you can see the aluminium internal panel. Again, I explained this before. The reason for aluminium inside is A, it matches the extrusion color, and B, it's shinier because it's it's a lighter color, which means it will reflect, which is also nice. We have foam insulation in between. This one is 13 millimeters. For the most of the panels, I will be going with 19 millimeters insulation. That's because the panels are 2 millimeter thick, so 2 millimeter thickness here plus 18 is the distance you have, and then the outer panel will go. So I will be squishing that 19 millimeter insulation a bit, which is not ideal. You don't really want to squish insulation, but I think that will still work better than 13 millimeter, which yeah, it will leave a large gap. But here the distance wasn't 18, it was 16, so I went with 13 millimeters here. For some reason insulation goes from 13 to 19. I don't know, it's probably some weird American freedom unit bullshit, but it is what it is. This panel is the only panel in the printer that's not mounted with screws. So the way this works is there are little cubes in there that I also stick, well, I didn't actually, never mind, that rest on the shaved down insulation, so that's the spacer there. And on this side, these clips have a 2 millimeter rubber tape behind them, and well, it's basically squishing the panel in place. As I said, this is the only panel without any screws, and that's because, I'm pretty sure that's because I couldn't figure out a way to use screws with these. The panels are designed to be removable without removing the insulation. That's what's making this a bit trickier. So in this case, On here actually you can see that I stuck the insulation on the outer panel, so if I remove these clips I can reach the inner panel, and that's attached by screws to the Z extrusions, and that's how it works. And here, for example, I'm not going to stick the insulation to this. I will be sticking the insulation to the outer panel. So yeah, this is designed to be maintained. I really shouldn't be doing what I'm doing right now with this hand, but whatever. There are some gaps in the panels which I didn't expect. I already have an idea for covering these up. I will just use some white silicone, but as I said, I will be reprinting the parts for this with high temperature material, so I will be waiting for that transition before I do that, because yeah, it will be a pain to remove otherwise. And for when it is printed out of the ABS, it doesn't really matter. So yeah, once I print the printer out of something higher temperature, I will be replacing those. But otherwise, the printer is going well. Removed the drawer here, but nothing wrong with it. It just was getting in the way. So yeah, I just need to do the gantry. I'm waiting for some parts for that. So yeah, basically the fans for the tool head. So don't know when that will be, but I'll be back with well, whenever that is, I guess, probably in a week or two in my case, but in a second for you. Mounted the gantry and also ran the belts here as well, so this is how it's going to look, except the layer fans, which will go here. I'm not gonna push that in yet because I have to do that after I do some wire management, but yeah, this is how it's going to work, and 2 screws will hold the layer fans and the extruder in place. So the extruder right now comes off. This is a custom designed adapter I did for the stock TinyM toolhead, though mine isn't exactly stock, it's slightly different, but should work for the stock one as well. So yeah, the orbiter mount, did I say TinyM mount? I meant orbiter. Yeah, it should work for those as well. So this is how it's going to work. As I said, I also ran the belts, and I noticed I made a mistake with my MGN9 selection. I chose the wrong type of carriage. So if you don't know, there are 2 carriages, MGN9H and MGN9C, and I chose the narrow version. I think the narrow one is C, and I was supposed to use H, so had to modify these and reprint them, etc. But yeah, they should work. They're not ideal. You ideally want the carriage to be wider so it wobbles less on the rail, but shouldn't matter too much. Also had to get rid of the gates idlers. That was what I was planning on using, but I just couldn't get them to not rub on the plastic parts, so I'm just using the bearing stack that's traditional on pretty much all Voron printers as idlers. These are obviously smooth idlers as a result, but which is not ideal, but should still work anyway. Also here I did the drag chain. This is a 3D printed drag chain, as you might have seen in the time lapses. I actually have a 15 by 10 or 10 by 15, whichever one, drag chain somewhere, but yeah, just couldn't figure out a good way of mounting it, especially on this side, so I decided to 3D print mine, and it seems to work fine. And also did the limit switch here, which actually I'm just using random shaft I have from one of the Voron 2 limit switches, so it's the perfect height, so I didn't have to bother cutting that. Had to replace this one, made it taller, seems to work. So yeah, did a decent amount of progress on this today. I don't think I'm going to be able to do much more. I'm still waiting for some wiring supplies, basically microfit pins, but should be able to finish this printer, well, get it working in the next episode. I'm also working on a modification to this style of Raspberry Pi heatsink. The problem is you normally can't really mount this heatsink, and only way of doing that is just by screwing it through the panel, so the head of the screw is on the other side of the panel, which if you've seen the rear electronics is not ideal. So yeah, I'm working on modifying this, basically drilling with an M3 screw, 3mm drill bit, M3 screw, great, and a wider drill bit so that there is room for the M2.5 screws head to sit. And yeah, should work, but I've broken 2 3mm drill bits already, so I'm also waiting for replacements of those. But otherwise, I just did some work on the backside as well, just basically some wiring. And well, yeah, that's it. But as I said, that's all I want to do in this episode. In the next episode, we will get the printer working, if nothing catastrophic happens, I guess. And yeah, we'll probably do a few things before the move as well, like lighting, chamber temperature sensors, maybe even an air filter. Not actually getting it in a working condition, but at least installing it so that I can just place the filter material after the move when I buy the correct type, and you know, stuff like that. But yeah, as I said, that's it for this episode, so I hope you enjoyed it. If you did, please leave me a like down below, and thanks for watching.